Good afternoon, all. Thank you for joining our webinar today on optimizing noise and vibration in electric machines virtually with SIMULIA Manatee. So, before handing it over to our technical speakers, I would like to give a brief introduction about our company, EDS Technologies. We help transform businesses by enabling adoption of virtual twin, geospatial analytics, and 3D printing. We have introduced many technologies like 3D printing, VR, digital manufacturing, etc., for the first time to Indian customers. We have established ourselves as a trusted partner for more than 2,000 organizations across various industries, which includes automotive, aerospace, defense, industrial equipment, mining, and others. We have dedicated regional teams who are reinforced by our domain and functional consultants. We are backed by strategic alliances with global leaders who are pioneers in their respective technology areas. We have a widespread presence with 11 offices across in India. We are an end-to-end technology solutions provider to our customers. So, our panelist for the day is Ms. Karine de Grendel. So, Karine is currently working as Simulia R&D Technology Manager at Dassault Systems, leading advanced research and development for electromagnetic and vibroacoustic simulation tools. She holds a master's degree specialized in acoustics from École Centrale Marseille and has deep expertise in noise and vibration engineering for complex systems. She previously worked as an acoustics engineer at General Electric and Dyson, focusing on noise emission and performance optimization across industrial applications. So, our technical speaker for the day is Mr. Vaibhav Adhikar. Vaibhav is currently working as industry process consultant at Dassault Systems, specializing in EMAG simulation across high frequency and low frequency domain. He possesses over 5 years of hands-on experience in full-wave EM simulations, supporting applications such as RF microwave systems, EMC, EMI, and electric machine analysis. He is actively engaged in e-NVH studies through the Manatee solution, addressing noise prediction and mitigation for motors. He has a strong expertise in simulation-driven workflows, model abstraction, and multiphysics integration to meet advanced engineering and customer requirements.
Thank you, Abhay and EDS team for the introduction. And all of we welcome all of you on this short webinar on optimizing noise and vibration in electric machines virtually with Simulia Manatee tool. And to know more about you for the today's audience, I would like to launch one simple poll question. So please respond to that poll question. So whether you are completely new to the e-NVH simulation, or uh, you are aware about the Manatee and you would like to learn how Manatee can helpful for you to address your simulation. So I request all of you to uh, uh, be, participate in this poll question. So okay.
So, people have responded. I'm just pulling out the results. So, almost all of them have responded that they are new
Got
to
it.
the NVH simulation.
Yes, perfect. Okay, okay. Good to know. All of are new to the e-NVH simulation. I will definitely modulate my speed as well as the approach for this presentation. And while considering the agenda, what I will start from very beginning, the introduction to the e-NVH, why people do care about the e-NVH. We will try to address these questions. And then we will deep dive into the fundamentals of the e-NVH, where we will try to understand the resonance, how it is affecting the noise levels. Manatee is a very well-known tool and customers are widely using it across the world. So we will also see some customer stories, how people have already used Manatee to tackle their challenges. Since it is a multiphysics tool, the e-NVH process itself is multiphysics in nature. We will, again, anyway, in upcoming slide, we will also reveal that what are the inputs and outputs that are required in order to do successful simulation with the help of Manatee. We will try to discover that part, as well as how you can visualize and interpret these results to get more insights and make the corrective measures. We will have one short demonstration, and of course, we will conclude our session in the last. Having said so, as Abhay was also mentioned, please feel free to raise your questions in the question tab. We will, at the end of the session, we will definitely answer as much as possible. So what exactly is the e-NVH? So when what what we said is basically the total noise. What we observe physically is the total noise. But I can decompose this total noise into three different components. So that first component could be a mechanical noise, maybe because of the structural interaction. You can see gearbox can be one of the example. Okay. Another component could be the fluid noise. Here you have the structural and the air interaction. Uh, so here fluid as well as the solid interaction is a crucial part to get the noise level. And the third component we might get ignored many of times, and it is not physically realizable. So that is the magnetic noise. So magnetic noise is so this magnetic noise is basically comes from the forces, magnetomotive forces, and these magnetic forces are basically induced by the magnetic fields, and these magnetic fields may be present into the coils or in the magnets, which are again inherent part of your motor. So if you are dealing with the motor or generator, any rotatory machine system, magnetic noise will be always there because of the magnetic forces, and that magnetic forces are basically get induced by the magnetic fields. And Manatee is very specialized tool to assess this magnetic noise and the vibration, which basically induced by the magnetic forces. These magnetic forces can produce a strong tonal, unpleasant sound level, and something we also called it as a magnetic noise. So, so having said so, why we really care about the magnetic noise, which is also in automotive terminology is known as the e-NVH. So of course, the first answer is end user expect that electrical system as silent as possible. However, the magnetic noise can be louder than your aerodynamic noise or your mechanical noise, and and there are multiple reasons here we want to reduce this noise. One, if I list down these reasons here, one could be like fulfilling the standard requirements. Another could be you may want your product to be different from the competitors, or in other case you may want product to be sound better as compared to your competitors. You may want to you also expect that product should not be get rejected during any subjective testing, as the product is lifelong. Lifetime should not be get reduced because of these vibrations. And of course the product must not disturb any surrounding life. So there are multiple reasons where we need to address and mitigate the e-NVH noise. And tackling this noise after the manufacturing process is very expensive, and it may degrade your electrical performance, such as efficiency, cooling, and weight. Thus, addressing the e-NVH problem at very early stage, at very design stage, becomes very important. This will definitely accelerate your development time and reduce the prototype, reduce your manufacturing as well as the testing cost. At the same time, the e-NVH risk. So, I would like to know uh, about in the next poll question how you are currently accessing your electrical machines. Do you have access to design of the electrical machine, or your supplier have, or your vendor have that access? So I request Abhay to launch the poll question.
Yeah, I have launched Viber.
Yes. So I would like to know your current situation where we would like to know whether do you own your electromagnetic design of your electrical machines or motors, or you many times not only the electrical engineer but also different teams are involved, so they may have access to the electrical drawings of the electrical machine, maybe in the XF file formats or anything. So please feel free to write your answer. And of course, if your option is not listed here, please type it into the chat box. We will definitely get back to you once we go through the recordings and the uh,
So
and the
I have the results, Vaibhav. The audience have voted. So about 50% of them have told that they or their team have access to drawings of electrical machines.
good.
About 33% people have told that they have external vendors who design the electrical machines. About
Understood.
17% of people have told that they design their own electromagnetic design of the machine.
Got it. Got it. Thanks, Abhay. This will definitely help us to get in touch with you in more accelerated fashion. Thanks, audience. So coming back to the presentation, so let me give you the fundamentals about the e-NVH. So why this tonal sound is getting produced, and the reason behind it is basically the resonance. So what is the resonance condition? So you have the electrical excitation, and this electrical excitation is going to produce the Maxwell forces, and this Maxwell forces will have some mode shape. Here you can see it is the radial shape, meaning magnetic forces are getting oscillating in the radial direction. Something we also known as the breathing mode in e-NVH terminology. And you also notice that this this oscillations, this mode shape is having the frequency of 8.5 kilohertz. Now, this on top of it, we also have the structure. This structure will also have its fundamental modal shape. Here you can see another structural mode, and it is also expanding and compressing into the radial direction. That too at the same frequency, that is 8.5 kilohertz. So if these both conditions are get matched, that basically results into the resonance. I will repeat. So if the mode shape from the electrical point of view and from the structural point of view gets matched along with the frequency, that's where the resonance condition gets satisfied, and you will see sudden spike in your noise levels. So That is something we definitely need to identify, and we need to resolve that resonance. Here, uh, now it becomes much more from this concept, the resonance concept. We will definitely came to know that in order to control your e-NVH noise, we should have the control, or we should able to predict the force frequency, the shape, as well as the magnitude of it. And let's see how Manatee can help in this. Now, you might have observed that this is the multiphysics process where the electromagnetic forces are giving, as well as the structural motion are going to get combined and giving you the e-NVH noise. So it is a multiphysics process, and here not only the electrical engineers but also the control engineers, mechanical engineers, or the NVH engineers are work together to address this problem. Maybe the control engineers or electrical engineers will work at the excitation level, whereas the mechanical engineers and the NVH engineer work at the transfer path. Could be addressing the structural or the acoustic issue. So all needs to be solved in a single user interface, and that's what Manatee is providing. So Manatee offers a unique solution, that is all-in-one physics solution to address the e-NVH problem, where all the engineers can be collaborate among themselves. Multiple teams can be collaborate between themselves to reduce your development cost as well as time. Not only this, Manatee also have the predefined simulation workflows, and and the fast and accurate simulation results will definitely help you to analyze the root cause of the e-NVH problem, as well as there are inbuilt mitigation techniques to reduce these e-NVH levels. Manatee has wide range of experience while addressing these e-NVH challenges. Manatee, initially developed by Emois in the north of France, and it was and they are serving more than they have already served more than 170 industry to to resolve the e-NVH levels by almost like 40 dB. Manatee has the wide range of experience in supporting various topologies, whether it is the permanent magnet synchronous motor, or your asynchronous motor, could be like induction machines, squirrel cage induction machines, or wound rotor synchronous machine, or even the generator. That too, your rotor can be on the inner side or can be outer side. And of course, the wide range of application, whether it is the from watt to megawatt, or from 5 rpm to 150 kilo rpm, you name it, we have the experience in the given industry. In particular, if I talk about the different industries here, so when it comes to the transfer and mobility industry, all the electrical traction motors, electrical pumps, or your steering motors, or high voltage AC motors, all are facing basically face the e-NVH problems, and Manatee is again a best tool to address that issue. When it comes to the industrial equipment industry, you might be deals with the pumps, compressor, generators. It could be like hydro generator or wind generators. So all in all area, Manatee definitely have the presence. Of course, when it comes to the aerospace and defense industry, you might be dealing with the drone motors, or electrical aircraft propulsion systems, marine and offshores, as well as the high-tech industry. Nevertheless, the uh, the the industry which are the revolve around their life science and healthcare. They all the electrical motors which are basically be used in surgery tools. So wherever the electrical motor or rotated machinery coming into the picture, Manatee will definitely help you to resolve your e-NVH problem. So let us hear like how our customer has already resolved their their problems uh, in different industry. One such industry, one example here I have is from the A&D. So in vertical takeoff and landing application, the magnetic noise can be critical as compared to your aeroacoustic noise, and it must be considered, it must be addressed early in the design process. So here, this specific customer wanted to compare different motors which was provided them by the suppliers, and they wanted to go with the very quietest solution. So traditionally, the electrical motors, the ENVH design is basically relies on the rules of thumbs, and which may limits your ability to accurately predict the noise behavior. This basically results into the high risk of NVH problem, particularly when you are dealing this you focus on the structural bond noise that are basically get induced by this or electromagnetic forces. And with Manatee, how they were able to address the problem. So they compare the different motor design systematically, and both they address the both airborne as well as the structural bond noise in a single solution. This basically enable them the early stage detection of the NVH level, as well as mitigating it. Uh, Here you can see, for example, these two motors. So having 24 slots, 28 poles, outer rotor was there, is of course have the less noise level as compared to 12 slot, 14 pole outer rotor. So in with this systematic study, definitely you can those who are who are basically rely on the vendors to get the motors, definitely make use of Manatee to compare different designs at a very early stage. Another example here I have from uh, uh, from the transport and mobility sector. Here, the noise was coming from the low speed RPM. So, and that was identified during the testing. Uh, in their current practice, the motor basically in order to resolve the ENVH issue, they often carry out the trial and error approach, which is which may incorrectly uh, scale your past experience to the new design. And e-NVH simulations are typically difficult to access, and therefore the regular design iteration as well as the what if scenario, they had the limited access to address such e-NVH level. And with the Manatee, they were able to do the simulation at a very early stage of the design, and they not only predict the noise of e-motor, but also the when the motor is getting mounted on EDU, so how the noise level will be there. So those things they were also able to predict. And by by making the use of the Manatee optimization, which is again inbuilt functionality of Manatee. They change the magnet angles, rotor notching, as well as the stator notching. And you can easily see the resonance has almost like reduced by 20 dB factor with the by redesigning the motor. So that's how the customer have used Manatee in the past. Uh, and definitely you can definitely get in touch with us to know to understand your situation much more in a better way. Having said so, let me focus on the next part. How what are the inputs and outputs that will Manatee will require to set up your simulation problem and to address and as well as to access the various results. So Manatee, till this point, you might have understood Manatee is bridging the gap between your magnetic circuit, electrical circuit, with with your structural circuit, and predicting the acoustic noise and the vibration that are arise because of the magnetic forces. And to consider, while considering this, there can be multiple inputs you can consider. So from the electrical perspective, you might want to have the voltage or current levels, the magnetic circuit geometry, as well as the material properties, the electromagnetic material material properties of your electrical machine. The next level of output could be to have the modal basis modal basis of your electrical drive. And this is this input is basically optional here, meaning if you want to go towards the higher accuracy, definitely you should include this electric drive modal basis in your simulation. Once once you give these inputs to the Manatee will definitely give the results, all the results such as the electrical, magnetic, structural, and acoustic quantities out of it. The root cause of the resonance you will able to identify. Then the single speed, variable speed, torque, as well as the speed plane you will able to observe as an output into the Manatee. So all the key quantities such as the current, flux, forces, yeah, are basically available as an output in Manatee. When it comes to analyzing the results, the Manatee is very sophisticated tool to infer from these results. So one such case we have here, we are plotting the sound power level versus the rotation speed. And once you click on any one of the graph, you will come to know the whether that noise is from the which forces, which mode is contributing, and of course at what RPM it is contributing. So the highlighted one is basically the H48 mode, and the main load cases are nothing but your R equal to 0, the radial and stator contribution of the R equal to 0 forces. That is nothing but the pulsating forces. And according to e-NVH theory, the resonance at these speed is because of the breathing mode, as we are highlighting here. Not only the the sound power level versus rotation speed, but also the sound power level versus the modal frequency graph will be readily available with you. And this modal tracking will again become helpful for you to identify which mode shape is contributing. So here in this case, the mode number 242 was closely resonating with the breathing mode that we are highlighting it here. So these once you identified this, definitely you may want to take the preventive action and you may want to mitigate the noise levels. And there are multiple uh, multiple things such as the parametric sweep or the optimization available in the Manatee to mitigate your e-NVH noise. And there are already predefined 15 plus e-NVH mitigation techniques, which which basically very minimally affect your efficiency level, but at the same time it drastically reduce your e-NVH levels. When it comes to the electrical engineers, they may explore these options such as changing the slot floor number, or changing the stator notching, or the coil pitching, or the pole shape. Similarly, another technique is the rotor notching. So in upcoming slide, definitely I will highlight you these techniques. So uh, so not only the electrical engineers, but the controller or the mechanical engineers can use different techniques to mitigate the e-NVH levels, such as the damping, mode shifting, or tolerance control. If and all these techniques which are already available in Manatee, like I mentioned, it negligibly affects your torque and efficiency. So so you can definitely use these techniques to reduce your e-NVH level. One such example, if I try to highlight it, here is the dual notch technique. Uh, Here you can see I'm going to vary. I have introduced this rotor notch, and I can make it as a parameter. The angle between these two notch could be like my parameter. So maximum till this part they will go, and minimum could be this. So in this variation, I can do the parametric sweep, maybe from 5 degree to 30 degree. And once I done this simulation, here you can see the for the motor where the notch was not present, the noise level has been the sound power level has been reduced from almost like 105 to almost 90 dB. So almost like 15 dB or 14 dB of reduction was observed with introduction of notch at the, let's say, angle between 5 to 10 degrees, somewhere close to 7 degree. Similarly, if you observe the torque at that operating point, you can also see it is minimally affecting the noise, minimally affecting the torque. The torque is almost reduced by 3%. So this parameter can be, this angle separation can be definitely a good choice to reduce your sound power level, at the same time maintaining your torque requirement. And this parametric sweep we have just computed only in the 15 minutes. When it comes to typically setting up the problems at each stage, you can see machine definition almost take 10 minutes. Variable speed and computation again will take 10 minutes. Result analysis are again you can 10 to half an hour, let's say. And if you are going for the corrective measures, definitely the parametric sweep and optimization will come into the picture, which typically from 10 minutes to 3 hours. So of course, the addressing identifying the noise as well as the mitigating the noise is definitely a half a day job with Manatee, and that too with user friendly GUI. So let's see how uh, how uh, how I was able to set up the model. First, I identified the problem, and then I introduced the notch to mitigate that level. So let's go into one small demo. So here you can see, if I turn on, yes. So here you can see I'm loading my machine, that is internal permanent magnet synchronous motor, and I'm solving the workflow for what this workflow is doing. It is variable speed, sinusoidal current excitation. I'm solving the multiphysics problem, and 1 second. Yes. So I'm solving the multiphysics problem, of course, and here I'm giving the workflow name, and the green box is basically where I will need to specify my inputs. So the current is basically my input, the RPM versus the IDIQ value can be act as input here, that I'm loading it, and I'm doing the variable speed analysis for the given motor. I can also visualize the results. So on top of it, the magnetic lookup table will be get computed. So for each operating point, we will map the magnetic properties, and we will prepare this magnetic lookup table. And either you can compute it into the Manatee, or you can load it if you have already available. To have the more realistic approach, I'm basically selecting the I'm selecting the modal basis from the abacus, let's say. So that too in the abacus, that too in Manatee file format. So I'm loading my electrical housing, and this is the housing you can see. So I'm also considering the modal basis, the structural analysis in this simulation, which has been done outside. Of course, you can have you can also compute the fully analytical solution or semi-analytical structural simulation are possible into the Manatee. You can then define the sensor location, let's say where you would like to measure the vibration levels. So those things, everything has been defined here in the modal basis. So now I'm set up with the model for the given machine. I will run my simulation, and within 5 to 10 minutes, I will have this multi-physics problem solved. Here I'm plotting the spectrogram, and you can see the significant modes. I'm also highlighted there the resonance condition, and here you can see for the at the higher RPM, you can see the sound power level. It is almost close to the 101 dBA, and that too at 1000 RPM. Sorry, the 10,000 RPM speed. Uh, if I back calculate the current levels, I can use that current point to modify my design. So here, to reduce that noise level at that particular RPM, I'm introducing the notch like I was highlighting. So here you can easily select the notch and set up the whether it is the dual notch or single notch. All these setups that I'm doing it here, I can specify the parameters, and this is my modified motor now. And for these notch, I will do the parametric sweep. Of course, I may want to modify I may interested in sound power level at particular RPM only. So that RPM only I will consider, not the variable speed RPM. I can for this point of time I can compute my magnetic lookup table, and I will set up my parametric sweep, that is the angle between my notch. So maybe from 5 degree to 30 degree in almost like 16 samples that I have considered, and I'm solving my model. And you can definitely compare the noise power level as well as the torque level, and you can choose the optimized design. Here is the design number 4, which basically giving me the optimal, where I'm drastically reducing my e-NVH, at the same time uh, minimum uh, a change in my torque value. So this design I have already considered. I will consider this as my final design, and for to ensure everything is working fine in all other region also, I will again rerun my simulation for the variable speed. And once I run that variable speed, of course I can compute my magnetic lookup table again for the new machine, and I will solve my problem. So again, this entire process has basically taken almost like half a day, and I was able to uh, identify as well as the mitigate the noise level at the higher RPM from 101 value dBA value to almost like 87 dBA value in this particular example. So that was the short demo, and of course uh, you can have the different at different level. The different optional inputs are available to help you out, and Manatee have the synergy between all the different Simulia products that are available with Simulia, the source system Simulia brand, such as, let's say, uh, you may you may import your air gap flux may be computed from the CST. You may calculate your modal basis from Abacus, or maybe your non-magnetic noise in the SIMPAC and or the softwares. So and all optional at various level, you can have the output levels so that you can have the communication between the existing softwares. When it comes to the licensing, it, you can easily see that I have the node lock as well as the floating license available. That too, these are compatible with the batch mode, so that you can call Manatee from the third party script if you wish to. Of course, if you have Manatee, you also eligible for the optional e-NVH coaching hours, where our experts of e-NVH will definitely give you the give an hour of given service hours to provide you to share their experience with your team. So with this, I would like to conclude my session. So Manatee definitely removes your e-NVH simulation bottleneck into the electric drive virtual prototyping workflow. It it provides the efficient workflow to assess, analyze, and minimize the noise vibration level due to the magnetic forces. And and you can check all n number of what if scenarios as well as the optimization technique that can be carried out by whether it is the electrical engineer or the structural engineer or the NVH engineer. So they need not to be the CAE experts. And as in the demonstration I was showcasing, Manatee is way faster than all the commercial tools that are available in market. It is almost like 1,000 times faster to get to solve to address your e-NVH simulation. And of course, you have the standardized interface, and there is e-motor integration between different or the collaboration between Manatee GUI with other software as well as within your team. And of course, the GUI it's very ergonomic in nature, very user intuitive, that that you can give it a try. So with this, I would like to conclude my session.
So yeah, I would like to thank Vaibhav and Kareen for delivering a very wonderful presentation and demo of the Simulia Manatee solution. I'm very confident that it was very helpful to our audience. I would also like to thank our audience for participating in this webinar, for taking their time out and being a wonderful audience. So please do keep an eye out for our upcoming webinars and seminars. We'll be posting that on our social media. So keep an eye out for the upcoming sessions. Thank you once again, Vaibhav and Kareem. Thank you all.